Welcome to another edition of CU Science Update. I'm your host, Ryan Palen. Where do you go for information during an emergency? Newspapers, TV, Twitter? According to CU researchers, people are turning to social media on the internet when they want to find out what's going on. Professor Leysia Palen and her team aim to develop specialized mobile and web applications to help citizens and officials during a large-scale crisis. The goal? Making viewing of information through social media accurate, credible, and timely.
Twitter is a good thing to study because it's a new kind of medium, and it's very popular right now, so there's critical mass communications. And we can imagine that next year or even next month it's not going to be Twitter that's popular, it's something else. So we try to be ahead of the curve and not follow we're not fascinated with the technology, we're fascinated by human behavior, and we look at the ways in which people are using technology to be able to behave and interact. And right now, a big one is Twitter, so we're spending some energy looking at that.
For years now, scientists have been alerting us to the consequences of global warming, including rising sea levels and increased storm intensity. Some claim that global warming is a natural part of Earth's climate cycle, while others argue that melting ice caps and increasing sea levels are caused by burning fossil fuels for energy. Adding to the fears of coastal residents, a team led by University of Colorado researchers has just published a study that found most of the world's river deltas are actually sinking due to human activity. About 85% of the 500 million people living on river deltas have faced severe flooding in recent years, due in part to the sinking of their land. For more on this story, we go to CU Science Update correspondent Ashley Hancock.
Thanks, Ryan. Using satellite data from NASA's Shuttle Radar Topography mission, a team led by CU Boulder professor James Savitsky has found that 24 of the world's 33 major river deltas are sinking due to human activity.
We looked at whether these deltas were being subsided by human activity, such as gas mining, oil mining, groundwater mining, and to what extent that was occurring, how long that was occurring. We looked at sediment input to the deltas from before humans had a major impact on the river systems.
Rivers transport sediments to deltas, which naturally build up the land. However, man-made dams prevent the sediment from reaching the delta, causing the land to sink.
I think that's one of the things that our group really brought into the picture, because we do a lot of sediment modeling. And so we model how we think the rivers were working before humans interfered and after they interfered with dams.
To illustrate human impact on river systems, Albert Kettner created an animated map of dams built in the United States since 1800.
You can see the first few dams are starting to pop up on the East Coast. Over time there's just more and more and more dams, and in only 200 years US is almost covered with dams. Those can be all tiny dams, but still it's massive how many dams there are around.
Few deltas have escaped the impact of human activity, putting both the land and its people at risk of flooding.
Right now there's about 10 million people a year that are getting flooded out, and there's thousands of people dying every year because of coastal flooding.
CU researchers are teaming up with scientists around the world to address public policies regarding sinking deltas and their impact on the community.
There's an organizing body that tries to internationally organize different countries that have big deltas, Delta Alliance. They're trying to strategize of what can we bring in to the mix of different policies and what are key things that we now need to focus on.
CU scientists believe that global delta flooding could increase by 50% by the end of the century if sea level rises by the 18 inches predicted by the Intergovernmental Panel on Climate Change. From the CU Research Center, I'm Ashley Hancock. Back to you, Ryan.
Thanks, Ashley. After America's experience with Hurricane Katrina, it's great to see technology being used to identify problems where people meet water. Our own Katie Gauthier sat down with Dr. Irina Overeem to find out how researchers are studying the world's sinking deltas.
Thanks, Ryan. Joining us today is Dr. Irina Overeen, a research scientist with CU's Institute of Arctic and Alpine Research and co-author of a study assessing the impacts of human activity on the world's 33 major river deltas. Welcome, Dr. Overeen.
Thank you.
So first of all, do you kind of want to tell us what you're doing and what this study was all about?
Yeah, of course. So in this study, we looked at an overview of 33 deltas worldwide. we picked like really major ones, like the Yellow River Delta or the Ganges Delta in Bangladesh. But we also looked at much smaller ones, like the Rhone Delta in France. And so we tried to get a variety of settings and a variety of differences in countries. And we try to assess in all those deltas how they're sinking to, with respect to sea level. And so sea level has been coming up over the last 50 years, and it's been projected that it will continue to rise over the next century.
That can't be good.
That can't be good.
So do you want to kind of tell us what your role was in all of this?
Yes, of course. We're like in a team at CU Boulder. It's called the Community Surface Dynamics Modeling System, and we're kind of the integration facility of that. And 4 or 5 of my co-authors are all in that team. And in addition to that, there are about 4 or 5 people that have been pulled in and that are experts in like smaller parts of the study. And so I did a lot of the map analysis and the tide gauge analysis.
So for that, you were saying, do you use satellites, or how do you get that?
Yes, we do use a satellite data set that's been recently released by NASA. It's called the Shuttle Radar Topography Mission Data, and it's got this incredibly high resolution of the Earth's surface. And so basically there's like points everywhere in like low-lying areas, but as well as in mountainous areas. And especially the low-lying areas are very accurate data, and so you can use it to into great detail. And so it enabled us to map out, like for every delta, like how much area is below sea level already, and then how much area is really low.
That's good that technology has come that far. So
yes.
Now that you guys have collected all of this data, what do you project? What do you want people to do about it?
So we found that in so many deltas, it's not just sea level rise that influences the delta. There's also a lot of human influence that aggravates the problem of the delta sinking with respect to sea level. And so it has to do with the rivers bringing in less sediment because dams have been built over the last maybe 70 years. It also has to do with mining in the delta areas of groundwater and oil and gas, and that compacts the sediment, and so they settle down even faster. And so I think we wanted to bring awareness of how fast deltas are going down with respect to sea level, and that increases their vulnerability.
Yeah, well, I wasn't aware of all this that was happening, so I'm glad that you guys did this study. But as, let's say, that I am the general public, what would you have me do as Joe Schmo off the street? Is there anything that I could do that would impact the Earth and better our deltas?
Well, I think that these are local problems for different deltas. But global sea level rise, that's something that we all, and so that'd be energy conservation, reductions of emissions. Those would be things that help in that part of the equation. If sea level doesn't come up as fast, deltas will be less sensitive.
Okay. So do you think that for each delta there's a solution for each different one?
It's hard to say, but we do recommend, like, I mean, there's millions and millions of people. We calculate there's about 500 million people that live in these areas. And so you can't say, like, okay, let's move out.
Right. That was one of my questions. What do you do with 5 million people?
What do local managers need to think about their coastal protection? How do they, are there different solutions for pumping groundwater out? Can they like do less of that? And there's actually a couple of success stories there too. Like one of the deltas in Italy, the Po Delta, they found that they were mining gas there, and they found that there's extremely rapid sinking. And then, because they recognized that and monitored it for a while, and recognized that it was caused by the gas mining, they stopped gas mining, and the rates within about 10 years, they were back to like normal compaction rates.
Oh, that's
and
good.
So there are things where managers, if they've got the good data sets and they've got a good idea of what's going on in their system, and they can balance all these factors like sediment coming in, sea level coming up, then that will help them in sort of taking these kind of measures.
So there's already some success stories. That's good.
Yeah, there are.
Which river deltas are at most risk, like the highest risk?
We were surprised by the prevalence of almost all deltas are at some risk. And like out of 33, we found 24 have like areas that are at risk. So that was really a staggering number to us. But then there's ones where we see that they're at greater peril than others. And I think the Nile is among those because of the Aswan Dam blocking so much sediment that never reaches the Nile Delta anymore. We also recognize that areas where there's hurricanes or typhoons, and if those, like they can set up really high storm surges where they push the water towards the coast. Those are much more vulnerable than areas where that doesn't happen. So there's Chao Phraya in Thailand would be one of the examples there.
Okay.
Yeah.
Are there any deltas in America that you can think of that are at risk? Or
I think the Mississippi.
Yeah.
I mean, it's got a lot of press, and it was sort of brought home to everyone because of Hurricane Katrina. And there's a lot of discussion about what are we going to do and how can we affect this system and still preserve its wetlands and make people safe.
Yeah.
But you need to do it with an integrated approach where you look at what does the Mississippi River do and what does the coast do, how does sea level come up.
Okay. What effects do you hope that this study will have on public policy?
Apart from this study, we wrote a policy document with about the same team and a couple of additional scientists. And in that document, we recommend that there be predictive modeling. And so development of tools that are both mapping with these beautiful data sets that come from satellites or from like global data collecting efforts. But also where you can like project into the future is like what would happen with the delta if this part of the system is affected in such and such way. And I think CSDMS here at CU that's like one of their key objectives, that we like provide these computer models that are predictive and that are about like what is going to happen at the Earth's surface.
God, that's so interesting. What other Earth processes are being looked at by the community surface dynamic modeling system?
There's about 300 people involved in that. And so it's a community effort. The scientists are over such a big variety of diverse, bringing very diverse expertise. And so there's glaciologists that look at like how do glaciers change and reach out and like melt back. But there's also people that look more at deep sea deposits. And so there's very different problems that people look at. One of the ones that I thought was really neat that we that the group identified to work on was on wildfires. It's like how does a landscape change like right after wildfires? And so like in California, when like some of those wildfires happened, then the winter afterwards, when you get big rainstorms, there's these big debris flows that happen and they like rush through the streets. Wow. And so we're trying to model those kind of things.
That's good. That's really interesting. And I'm sure it affects a lot of people. Another important question that I wanted to ask you was, how do you plan on getting us all involved?
I'm not sure the scientists always think that much about that.
They're more concerned about finding the data and collecting
We're trying to like make the assessment of what's happening right now based on the data.
Okay.
And but we do get involved in strategic meetings about like what's happening in the world deltas. The CSDMS effort has a strong missive to work on like predictive models, and that's a tool that we want to provide to society. Like the climate community brings in tools that project outwards in time and help out in sort of saying like, okay, this is a possible future for us, and what are we going to do or adapt to that?
Well, on behalf of the community, I want to thank you for all of your efforts and all of your research that you guys have been doing. I think it's great that you guys are putting all that effort into that. So thank you so much for joining us, and back to you, Ryan.
Yikes! It sounds like we should find a new way to prevent any further damage, or more people should just learn how to swim like Michael Phelps.